First homework of the proportion unit. All right, this is good stuff. Let's get started. All right, so the main thing we learned in class today is when we're solving these, we're going to use a technique called cross multiplication. Now, is this any different than what we've been doing all along? Not really. We're just kind of condensing two steps at once. Instead of doing the multiplication in two separate steps, we do it all at the same time. It saves you time. It gets you the answer quicker, so you're welcome. All right, so we're going to start 7 times 18 and 5 times k. So 5 times k is just going to become 5k. The equal sign is going to come right down. So 5k equals, and then 7 times 18 is 126. At this point, you're left with just a one-step equation. All right, divide both sides by 5, divide both sides by 5. K is going to equal 25.2. All right, so we've got that. All right, so let's move on to the next one. Same general idea here. We've got our fractions, we've got our different pieces, we just cross multiply. So we're going to have 5 times w, we're going to have 9 times 8. So 5w, again the equal sign comes right down, so 5w equals, and then 9 times 8 is 72. Divide both sides by 5, divide both sides by 5. 72 divided by 5 is 14.4. So W equals 14.4. Okay, so let's move on to number 3 here. All right, main thing here is just watch your negatives. Very easy to forget them, very easy to lose points. So just when you're doing this, we've got a negative times a positive, so negative times a positive is going to give us negative 36. 6 times m is just going to give us a regular 6m. Negative 36 equals 6m. Divide by 6, divide by 6. Negative 6 equals m. Okay. Last one on the front here. We've got 3/4 equals x over 10. So again, just cross multiply. Cross multiply. 3 times 10 is 30 equals 4x. Again, it doesn't matter what side I put each of those on. I could have had the 4x on the left and the 30 on the right. Doesn't really matter. It's your choice. Divide by 4. Divide by 4. X is going to equal 7.5. All right, so that's the front. Let's take a look at the back where we've got some of our word problems. All right, so on the back we've got unit rates. Now the important thing to remember about unit rate is it always means for one of something. 1 ounce, 1 hour, 1 whatever, it's always one of something. So this first question says, David went to Planet Fitness yesterday. He burned 600 calories in 1.5 hours. Find the unit rate. How many calories did he burn in 1 hour? All right, so there we go. Unit rate. How much did we do in one of something? So the way we're going to set these up is we're going to make a key. We've got two different things going on here. There's two different things the problem tells us about. It tells us about calories and it tells us about hours. So what we're going to do is we're going to set up a little key. We're going to say, all right, calories on top, hours on the bottom. And it doesn't actually matter which order I did this in. I could have put hours on the top and calories on the bottom. You just have to make a key, and then once you make that key, you have to stay consistent. And here's what I mean by staying consistent. So it says he burned 600 calories in 1.5 hours. So when I set up my problem, it's going to be 600, and that's the calories, which I'm putting on top, because I said calories goes on top, over 1.5 hours. Equals, I'm trying to find the unit rate. I'm trying to find how many calories he burned in 1 hour. So since we're talking about 1 hour, the 1 needs to go on the bottom because that's referring to hours. Again, our key is consistent. Hours, hours, hours. And then my x is going to go on top because that's what I'm trying to figure out. How many calories I burn in 1 hour. Once you've set it up, that's kind of the hard part. At this point, it's just going through the cross multiplication. So we've got 6 times 1. We've got 1.5 times x. Again, it doesn't matter which one goes on which side, but 600 equals 1.5x. And then you've just got the single step of dividing by 1.5, dividing by 1.5. 600 divided by 1.5 is 400. So x equals 400 calories. That's how many calories David burned in 1 hour of working at the gym. So looks like he got in a pretty good workout. All right, let's take a look at the next one. Number 6. A 10-ounce bottle of shampoo costs $2.40. Find the unit rate, i.e., how much would it cost for 1 ounce? All right, so on this first homework, we're kind of being nice, and we're saying, how much would it cost for 1 ounce? How many calories did he burn in 1 hour? But you need to get familiar with the term unit rate because we're not always going to give that to you. You have to know that it's per one of something. But again, the setup is the same idea. We've got 2 units going on here. We've got ounces, and we've got money. So there we go, ounces and money. Now the problem tells us that 10 ounces cost $2.40, so there's our first fraction. Ounces on top, money on the bottom, equals how much would it cost for 1 ounce? Well, again, 1 is referring to the ounces, so the 1 is going to go on top, and the x is going to go on the bottom. All right, so once you have that, it's just a matter of actually kind of doing your cross multiplication here. 240 times 1 is going to stay 240. That's the identity property. Anytime you multiply by 1, it doesn't change. 10 times x is 10x. Divide both sides by 10. Divide both sides by 10. And x is going to equal 0.24. So basically what we're saying is it's 24 cents for every ounce of shampoo. Now if you're going to put units on this, it's either got to be this, so money for 24 cents, or it's got to be this, where you say 24 cents. What you don't want to do is write this right here. This would kind of be your mixing and matching things, and this would be 0.24 cents, which is technically less than even a penny. So this one is no good here. You either want the 24 cents or the dollar sign with a 0.24. Either one of those would be fine. All right? And that is your first proportion homework. Hope this helped. Have a good day.